In this example, we're going to conduct one more hypothesis test with all the steps and bells and whistles to make sure we really understand the larger type questions. So in a study from 2015, the Pew Research Center found that 1/4 of adult Americans paid for almost all their weekly purchases with cash. A credit union researcher believes the percentage has decreased since then. They conduct a poll of 1,068 random adult Americans and find that 18% of them make almost all their weekly purchases with cash. And yes, that's real data. That's what the source means. Okay, explain why this study must have been an observational study and not an experiment. Oh, that's a little bit of a review question. Experiments require random placement. So you have to be able to randomly assign people, as the researcher, to use cash versus use credit card or whatever else they're using. And so that's not good, right? We can't make that. We can't enforce that. That would be too hard to enforce. So it would be not impossible, but very difficult to randomly place people into the cash group versus the credit card group. So I just wrote that down. Also think about it just a little bit. From experimental design, we prefer it when people, if you're going to be randomly placing them, don't know what group they're in, right? If they were blinded. But it would also be impossible to have blinding in this case because people are going to know whether they're using cash or credit cards. So not only is it really difficult to force people to be in the cash group or the credit card group, especially if they don't have a credit card, but it's even harder to maintain that, and then they would never be able to be blinded, right? So I'll just make a note. Also, blinding is impossible. So one of the advantages you would get from an experiment, which is blinding, you can't have it anyway. So you might as well go with an observational study. Okay, so what are the researchers' hypotheses? So this would be our step 1 if we were looking at our steps, right? So step 1 would be H0 and H1. And I'm going to write them in symbols, of course. Okay, so H0 would be the value that we assume to be true unless we can prove it otherwise. Usually it's from the past in problems like these. So in 2015, the Pew Research Center found that 1/4 of adults pay, that's a proportion right here. We assume that it's 1/4. So we assume that P is equal to 1/4 unless we can prove it otherwise. And therefore, once we know that's 1/4, then we know that's 1/4. And then the credit union researcher believes that the value has decreased since then. So that word right there, that's decreased. That's less than, right? So lower. Again, you don't have to write the word less. I'm just reminding you that that's what that direction means. If the pointy end is on the left, that's a less than. All right, now we're going to take a moment and we're going to verify our requirements. So let's go back and look. So we've set up our hypotheses. We've got that it's a left-tailed test. It didn't ask, but it's left-tailed, right? It's a less than. And by the way, if ever you lose sight of like which one's which, left-tailed looks like this. And so that can kind of cue that that's less, right? Because it's pointing to the left, right? It's got the left side shaded. As a right-tailed, this is the symbol for right-tailed, and that's like this. So that's a greater than. So if you forget which one's which, you can always look back here and kind of remind yourself, that goes with that picture, that's less, that's lower. This goes with this picture, so that's greater, right? So right there. So no need to be afraid by the symbols. It's a little confusing. So, all right, but what I was going there for was the random independent normal piece, right? Those are the requirements. Those are the conditions, I sometimes call them. Okay, so random. Random is given, so that's easy. It will not always be given, particularly in some projects that you guys have to work on, but most of the time it's given. And by the way, the reason it's given is because it says random somewhere. They're right there. That's why it's given, right? It actually literally is written in the problem, right? So it has to be written in order to be given. If it's not written, then it's not given, which is why the one earlier in the section was a typo. I meant to write it. All right, so Independent is going to be a yes, but let's prove it. To be independent, we need less than or equal to little n less than or equal to 0.05 capital N. Okay, little n is our sample size. So let's read up in here. Little n is 1068. It's right here. That's our little n. Lovely. Okay, so I can go in here and I could say 1068. That is less than or equal to 0.05, and then it would be 250 million because I gave you the value on this one. Or you could write all adult Americans. That would also work. So this is of course, right? Of course it is. I don't need to find the number. I know that this number, 0.05 of 250 million, is huge. So 1068 will definitely be below that, no problem. Now the trickiest bit is the normal piece. Now normal is n times p0 times q0. N we know is 1068 times, all right, now P0, we have to go back up and find P0. P0 is the proportion from the zero hypothesis. Sorry, I went too far. Well, I could go here too. It's this, right? I should have written that right here. P0, it's right here. So P0 is 1/4. So P0 is 1/4. All right, so then I need Q0, and then I'll have it. Well, Q0, you have to remember, Q0 is, we'll just make a little note. Q0 is 1 minus P0. So that would be 1 minus 1/4, and 1 minus 1/4 is 3/4, right? Because they make 1. They're complements of each other. So this is 3/4. That's just a little reminder of how to do that. Okay, so I need Desmos because I don't know what this is. So let me go grab Desmos. All right, Desmos. Oh, first of all, 1 minus 1/4. See, it's 0.75, but if I flip this little button over here on the left, it'll turn it into a fraction. So it's 3/4, just for starters. And then 1068 times 1/4 times 3/4. Now, this particular one you could do with the decimals, but some decimals don't work out. Some fractions don't work out to be nice decimals, in which case you're better off with the fraction. So if it's given to you in a fraction, keep the fraction. So it should be 200.25. And we're going to make a note. 200.25 is bigger than 10. And we're going to make ourselves a little warning right here. Keep the fractions, right? Don't switch them to decimals. This particular one was okay, but if you're using fractions, stay with the fractions. Now, if the problem was given to you in a decimal, that's fine, right? That happened to us earlier for our earlier example, right? So we had 0.24, and so we did 0.24, no problem. But here, because it's given to us as a fraction, we keep the fraction, right? Don't switch to a decimal for this particular part. And that's because some decimals don't work out nearly as nicely. So this is great. So 200 is greater than 10, so this is a yes. So we have yes, yes, yes. We are set to go. We have verified our requirements. All right, so now we're going to run the test. Step 1 we already know. Step 1 is P equals 1/4, P less than 1/4. Step 2, and yes, you should be labeling your steps. Step 2 is your alpha, which if you read here, they say 0.01 level of significance. Well, that's alpha. That's the probability of a type 1 error. That's what that is. Step 3 is the step everybody hates. It's the formula. So it's p hat minus p0 over the square root p0 times q0 over n. If you don't believe me, oops, my square root's not low enough there. You can see it right on the formula sheet. There it is. I'm using that one. Again, you could use this one, but it's not important. You just have to pick one of them. Okay, so let's see here. Big square root All right, I know that my n is 1068. I know that my p0 is 1/4. So I can put 1/4 right here and 1/4 right here. I know my q0 because I just found it. It's 3/4, so it's right there. So the only thing I have yet to find is my p hat. And then once I have that, I'm good. Ugh, my 3/4 became a blob. Sorry about that. Let me try that again. 3/4. There we go. All right, so if I find my p hat, I'm golden. P hat, let's see, is right here. It's the percentage given for this sample, not the percentage or proportion for the whole problem. Right? This is the one from the past that we assume to be true. This is the one we're using to challenge that. So this is our p hat. So 0.18. You definitely want to switch it from 18% to a decimal because decimals are how we do math. All right, we're going to stick it into StatCrunch and get the result. Right, you're looking for the z-stat. I should say use StatCrunch. Right? And you're looking for that z-stat. All right, so let's go to StatCrunch because we are not doing this by hand. No, 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 no. Okay, so in StatCrunch, we're in trouble. So if I go to stat, proportion stat, one sample with summary. I know that I want the p to be 1/4. I know I want to make it a less than. Right, there's my HO and there's my H1. I know I want the p-value plot on. I know my number of observations, that's n, right? So that would be 1068. But I'm in trouble. I don't know my number of successes. I don't know x. X wasn't given to us in this problem. So we're going to have to go find it. Okay, so we need to make a little note somewhere, anywhere. Let's do it over here. So we're going to have to find x. Now remember, we learned that x is p hat times n. Oops, and that's because p hat, if I write it over here, p hat is x over n, so that means that x is p hat times n, right? We've learned both of those formulas. Okay, so that means that x, which is my number of successes, is p hat, which is 0.18 times n, which is 1068. So I need to go grab Desmos, because I don't know what that is off the top of my head. All right, so let me say p hat 1068, 0.18 times 1068, and we get 192.2, and we're going to regular round that to 192, because you can't have 0.24 of a person. So this is 192.24, which we would say is 192. Regular rounding. Okay. Okay, now I don't need it for the problem. I don't need to put it in here anywhere. What I need it is in StatCrunch, because in StatCrunch, that's the number of successes. It's 192. So if I put the 192 I just found, the 1068 and so on, and I say compute, there we go. Now, again, this page doesn't really have what I need. You can double check yourself that this is the P and the P's, the H0 and the HA or H1 that you wanted, and it is. But if I go to the next page, I can see my z-stat. The z-stat, which is my answer for step 3, is negative 5.3. And my p-value is less than 0.0001. Haha. Okay, so this is negative 5.3. And for step 4, which I'm going to squeeze in over here, I'm going to draw a picture. It's going to have a really big left tail because my z0 is negative 5.3. So I'm going to draw it all the way over there. And this little tail right here is my p-value, which was less than 0.0001. You might want to make a note to yourself. X is the number of successes. So let me write it over here. This is the number of successes. We learned that technically we learned it back in chapter 6, but we ran into it again in chapter 8 and then again in chapter 9. So X is the number of successes, right, as opposed to N, which is the number of observations. Okay, so now we just have to make a decision and write our conclusion and we're done. So that p-value, whatever it is, because I don't know what it is, I just know it's really, really, really small, is less than 0.0001. My alpha is 0.01, which I can see in step 2 right there. So whatever this is, it is smaller than that. And therefore, we reject HO. So we just need to write a conclusion, and we're golden. So whenever we reject HO, we write the script. There is sufficient evidence to support the claim that... Okay, so now what was the claim? So remember, you kind of look for this word. So decrease, the percentage has decreased. Percentage of what? It's the percentage of people that pay for their weekly purchases with cash. So the percentage of people that pay for their weekly purchases with cash has decreased. So that's what we'll say. The percentage of adult Americans who pay for their weekly purchases with cash has decreased since, and it was said then, but then was 2015. It was the value or the time frame that we got our original value from.